Meet Mr. Ng, our math wizard's grace. In numbers realm, he finds a space. Equations unfold with a skillful hand. In math class where understanding expands. Oh, Mr. Ng, numbers at your command.
Question 1a, based on the graph, how many zeros does the polynomial function have? I'm going to answer this question in multiple ways, and I don't even need to use the graph. So, how many zeros? I'm actually just going to look at the degree here. The degree tells you how many zeros you have. In particular, here's an equation you had in your formula sheet, is the number of real zeros plus the number of complex zeros equals the degree. So if you have a fourth degree polynomial, that's how many possible zeros that we have. Okay, so the answer is 4. Here is a second way that you can figure this out using the graph. You can look at these green points, they call these turning points. Let's write that, turning points. They're kind of like the point in which you make a U-turn if you are driving. And the reason why they call these turning points is because I'm increasing, and then at that point, which is an extrema, max or min, in this case it's a max, then it turns to decreasing. So in this problem, I have 3 turning points. And the formula is the degree minus 1. So let's just say you don't even have a formula, you just have the graph here. You just solve for degrees. So I just add 1, and you'll have the degree to be 4. So a second way to show you how the answer is 4. And here is a third way that I know the answer is 4. You can look at the x-intercepts. So basically, zeros are how many times visually it crosses the x-axis. And if it shoots through or goes through the x-axis, then it counts as 1. So this, try that again. This is 1, 2, 3, 4. So that is a third way of showing you why the answer is 4. Okay, part B tells us now what are the zeros of the above polynomial function. Well, we can do this visually because we have not learned other methods. And basically, here on the x-axis, this is x equals -4. This one is x equals -1. This one is x equals 0. And this one is x equals 2. And so the only one that has that is choice C. Okay. This one works, that one works, this one works, that one doesn't work, so that's why it's not A. If you only have 2 of these and it doesn't tell you anything about multiplicity, then this would be a second degree polynomial. So not this one, and this would also be a second degree polynomial. Alright, let's go over question number 2. Part A here says, which function has a local minimum of a value of -1? So if I go down to a y value, and I'm going to make my purple line there, does any of those graphs hit that purple as a low point? Well, the blue one does not, f of x does not. The g of x goes, that purple line goes through it, but it's not the low point. And if you look at h of x, here is a maximum, and then it goes this way and hits here. This is a minimum. There you have a max. Okay, so that means, which one of these? That would be h of x. Okay, part B. What is the minimum value of the g of x? So now I'm going to focus on the pink graph. And you'll notice in the pink graph that the low point here is this one. So I'm just going to highlight that, and you'll notice that the y value is -5. That was the clue I gave you guys. When you write the minimum, you are writing the y value. It's just a number. All right, let's move on to question number 3. Which function has 2 zeros? So actually the same graph as the previous problem. Which one has 2 zeros and an even multiplicity and a leading coefficient? Okay, leading coefficient basically says, you know, when the a value is negative. And what that does is it basically just, it reflects it. Let's write that, reflects over the x-axis. Okay, which one is kind of turned upside down basically, and the only one that has that is h of x. But let's confirm that with the other clues. It has an even multiplicity. That basically means that at the x-axis there is a bounce. That's what even multiplicity means, right? There is a bounce to the graph, right? It bounces off, it kisses the x-axis and runs away. So we have that in here and here. Okay, and then the last clue is there are 2 zeros, okay? And the zeros are x equals -2 and x equals +2. So that kind of confirms why h of x is our answer. Fill in the blank square so that each row and each column contain all the digits 1 through 4. Numbers and cages may repeat as long as they are not in the same row or column. So the darkened ones are a cage, so I need 3 numbers that multiply to be 24, 3 to multiply to be 2, 3 to multiply to be 6, 3 to multiply to be 8, and 4 numbers to multiply to be 24. Definitely use pencil. Alright, so my strategy is I can only use the numbers 1, 2, 3, and 4. I like to write that down, super helpful for me. And 3 numbers that multiply to be 2. Well, I'm thinking of 1 times 2 times 1. And in the corner problems where you have to repeat a number, put those apart because they're not repeating in a row or a column. So I'm missing the numbers 3 and 4. So if I do 3 and 4, watch this. 3 times 4 is 12. 12 times something equals 24. That's going to be 2. Now I'm not quite sure if the 4 and 3 are in the correct order, so I can just keep going and then see what happens. 2 numbers that multiply to be 8. Okay, so I can choose 2 times 2 times 2, but those are repeating numbers. So I'm thinking of 1 times 2 times 4. Now, if I put the 4, I can put the 4 over here, but that means I have to put the 1 and 2 here. So I'm going to try erasing the 4 and the 3. And just switching the orders. Now I can do something like 1, 4, and 2. 1 times 4 is 4, 4 times 2 is 8. And again, I can switch the position of the 4 and 1 later if I need to. Let's keep going. And you could have done this in multiple ways. I'm just showing you what I'm doing. That's the first time I'm looking at this problem. So I'm thinking to myself, 36 has to be like 4 times 9. 4 times 9. So if I get 4 times 9, that would have to be 4 times 3 times 3. Now you'll notice my repeating 4s here, so we talked about how it made me just go back and switch these two. So I have 4 and 1. Okay, so that's 12, and then 12 times 3 is 36. Now I just need to fill this in. 4 numbers that multiply to be 24. And basically what I'm going to do here is think about where I can place the numbers in here. So notice how you have to have a 3 in each of these columns here. I'm missing a 3 here and here. I can't put the 3 here because it's repeating, so therefore the 3 has to go here. Let's see if we see some other numbers that are like that. How about the 2's? 2, 2, 2. We're missing a 2 here. Can't put a 2 there, so 2 has to go here. We're missing a 1. 1, 1, 1, so the 1 has to go there. And of course that one has to be the 4. Let's double check.
If you love my pretty mud, let's begin to try to with me, and you will get the score. Better score, and then try again with me. Let's begin again right now. Again.